This is The Science Behind the Soldier, a podcast from the Combat Capabilities Development Command Soldier Center.
Hey, Soldier Center, welcome to our third installment of our podcast. And, we're doing these podcasts for a couple of reasons. One, it's really to introduce someone in the organization or a facility within the organization to people within the organization that may not know it even exists. But it's about the people, right? Trying to introduce someone that you may not know. As a matter of fact, I just screwed up his last name, and I apologize. I always thought it was Bracken, but it's Brack. But anyways, we have Eric Brack with us today, and he's going to talk to us a little bit about how he got here, what he does. But I will tell you, not to surprise anybody, he does a lot of work in water purification and providing water to our soldiers, which is incredibly important, right? I mean, there's three things soldiers always need. I always say the most important thing on a battlefield for a soldier, and it starts with ammo, water, and plasma. Those three things you cannot survive on the modern battlefield without. I didn't even mention food, right? Because you can survive without food. And I'll tell you a really quick story. When General Cruller was here some time ago, he told a story about, I don't know if it was his dad or grandfather. It must have been his grandfather that was in World War II in the Pacific. And that his unit that he was with was fighting the Japanese, and all they had was water. They did not eat a single piece of food for 19 days. So think wow. About that, sustaining yourself in combat, sustained combat for 19 days, and thank goodness they had water available to them, right? But no food. And so that's why I put those three things kind of in that priority while they're important. So anyways, Eric, welcome to today's podcast.
Thank you very much.
It's great to have you here. So first thing is I always like to start off with kind of your background a little bit, where you went to school, actually where you were born, brought up, where you went to school, and kind of what brought you to the Army. How did you figure out this place existed, and how do we entice you to come and work for us?
Great. Thanks. So Eric Brack.
You sure it's not Bracken? Yeah. I'm pretty fun. It's Bracken.
Yeah. Okay. I'm local. I was born and raised in Holliston, Massachusetts, right down the road. Yep. I was silly and bought a house there, so I live there currently, nice. Which is great. Short commute, right? 20 minutes. My background, I went to Framingham State, which is right down the road as well. Yep. My degree is at ACS, or American Chemical Society, accredited degree in chemistry. Yep. So, chemist. From there, I went to Dow Chemical. So I worked in the electronic materials division there in Marlborough.
How long?
3 years.
Okay.
So we did, electroplating chemistries, lithography, working on solar panels, a whole array of things. Nice. So much drastically different than what I work on right now. Right. But, some of it still overlaps with some of the sensor work I do. And then I ended up here at Soldier Center.
How?
Exactly. The big question, right? So interesting story. Yeah. So I was at Dow, and my college advisor at Framingham actually reached out to me and said, hey, you're doing a bunch of heavy metal analysis because we kept in contact. He said, yeah. He said, would you mind, helping out on a project potentially at Soldier Center? So I said, okay. So I came in and met with the PI of the project. I was working with Nicole Ferrardi, my current team lead, Tom Tiano, and Joel Carlson was here, throwback name. And so, they came in and they said, hey, this is could be a full-time job after we started talking. So I was talking with them, and then, after, further on discussions, Tom said, and then we had talked with Jacqueline Fontecchio, and she said, we could actually make this an actual position, which was great. So a couple months later, I applied, and now I'm here. Wow. And, I've been here almost 10 years.
Goes by quick, too.
Goes by quick. And, not only in that quick span of time, I went from doing kind of almost lab tech work to now I'm running the hydration program here at Soldier Center.
That's pretty good, yeah.
So, in that 9 years, you go from, really that lab to, internal proposing, external proposing, really learning how Soldier Center works, kind of that R&D, just kind of working my way up. And now here I am running, a whole, 10 different, 20 different projects under the hydration program.
Yeah. And we talked about the criticality of water earlier. I mentioned that, right? It's so important for soldiers, but it's more than just, providing them water, right? You and I talked about this a little bit before the podcast started, but, it's the gamut of not just purifying water or desalinating water, but it's how you carry it. How do you carry it in hot climates? How do you carry it in the Arctic? Matter of fact, you mentioned Jacqueline. She's up right now traveling up to Alaska.
Okay.
Yeah. She's going from 23 degrees to minus like 23 degrees. She's going to be in shock. But the point is, how do we transport water? How do we make sure that it's portable? So kind of go into like, I guess talk about some of the projects you're doing within hydration, right?
I can do that.
Be a little bit more specific, kind of from carrying all the way to desalination.
Yeah, I mean, I'll talk about the projects, but yeah, like you said, the importance of water, and just for the Army and stuff, we can talk about later. But like that's just it's groundbreaking, some of the stuff we're doing. But yeah, so right now, kind of the biggest most well-known project I'm working is soldier and squad desalination.
Right.
So that's a very unique technology right now. We're using ion concentration polarization, and that is a collaboration with MIT. It's completely novel, completely innovative. Usually you're seeing, advancements in membranes and membrane technologies, but this is totally groundbreaking, totally different. We're using kind of electrochemical process, and it's cheap, low power, small footprint, and that's not something you have. And you're right, the Army has the rope use. We've got these big trucks, and for a squad, that's not suitable, right? You're not carrying this tractor truck around with you. So no, it's really innovative. And the thing about this technology too is that it can be used everywhere. Indo-PACOM, it can be used AFRICOM, across the world. But because it's so small and portable, I mean, human disaster relief efforts here in the United States, right?
Or worldwide. Third world countries, right?
Third world countries,
water is one of the resources that unfortunately is dwindling. Clean water, I should say, not water, but clean water.
Yeah.
Or the availability of clean water across the world. And so when I first saw this technology, I was incredibly enthusiastic about getting it to soldiers. But then, you and I have talked before that it's also got such a commercial base to it, right? Which is important. Yeah. So that's some of the things we do at the Soldier Center. I think people forget that could have dual use, technology. So we create it for the Army. But then again, it's used in the commercial sector. It'll advance there too.
Exactly. That's a whole thing. I mean, that's one of the reasons why I like working here, right? Yes, our mission is to make something for the soldier and, throughout the DoD, get this fielded for its critical need. But the need is beyond that. Everyone needs water. Yep. And you're seeing, the water scarcity, water security problems. And in those areas, the water is turning more and more salty or brackish. And, it's not fresh water, right, so you need a way to desalinate.
Yeah, absolutely. No, I think that's important. So, talk to me a little bit about anything you do for cold weather, though. We got, like I mentioned, we got people out there this week. I know Jeff and I going up in the middle of February, and one of the things I've noticed, just from my perspective anyway, was I was there. A water buffalo that the Army uses, which is a 250 gallon, I think, tank on the back of a trailer. Mm-hmm. We've had those forever in the Army. Yeah. And they actually have a heating unit that goes with that. It's a small outside that hooks into it, gas generated heat, or gas. It's a heating unit, but it's gas generated, I guess is the word I'm using for. But anyways, very inefficient, uses a lot of fuel to keep it warm constantly. And when we were out in Norway, we saw a really unique system that did everything: heat, cool, purified water, all in one unit, right, on the back of a truck. But anyways, talk to me a little bit about thoughts, in the cold weather and kind of what we're doing at the individual soldier, and then any thoughts you have about, larger operations.
Yeah, perfect. Yeah, so I don't know if I can talk about this, but I'm sitting on, I do sit on the water and wastewater subcommittee for the ice paper working group. And so that's with a bunch of our allies. And so, that's the big capability gap. Everybody, all of our partners, how do you keep water liquid in a frozen environment, right? So that's key. Everyone has that problem. And so one way we're going about tackling it is cold weather canteens. So maybe there's some work here, not just my team, but different ways of looking at thermos technologies. One thing that I'm doing with my team is I think you're aware of the battery bag that Paladangelo is working on.
Absolutely.
So seeing if we can make that a multi-purpose bag and see if we can use that to heat perhaps a molly bag or things like that, and then using some sort of new aerogels or different types of gels to make it, if you can't heat it, at least insulate it enough that it doesn't freeze.
Doesn't freeze, yeah. And then, I know soldiers will do all sorts of things, keep water inside their coat to stay warm.
So, right now, currently what's done, snow being melted,
Yeah.
right?
Yeah.
But you don't know what contamination that has, right?
Exactly.
And we know that you get, different dust particles and things like that, and pollution comes out in that snow, and you're drinking it, so you don't know what threats are there. And then there's regular canteens, right? But those freeze, and worst case, sometimes people keep these when they're sleeping. They keep their canteens in their sleeping bag, and then it opens, and now there's a whole array of other problems.
That is a whole other problem. It's funny you talk about melting snow, right?
Yeah.
So I know soldiers do that all the time, right?
Yeah.
That's how they get their water. But that's in a relatively clean environment.
Yeah.
If we're in a combat environment, right?
There's no way.
You don't know if there's any chemicals out there. There could be, you name it. There's sewage, there's waste products, there's, explosions that create dust and particles all over the place. So, that's the last thing you want to do. Do you do any work, or I should say, are we doing any work in detecting the purification level of water, or whether it's potable?
Yeah, definitely. So I have a whole 6.2 program in water sensors.
Right.
And so I've been working closely with Defense Health Agency, formerly Army Public Health Command. So we know kind of what RD targets they're looking for in water. And so, right, that's one big conversation about with PEO Soldier, right? PMSCIE. If we're going to field all these water purification devices, how do we know where they're working in real time, right? We're still taking water and globally shipping it back to Defense Health Agency for analysis. But if we had something that the soldier had cheap and portable, lightweight, and you could actually do a quick diagnostic to know it's working, that would be huge and groundbreaking too, right? So I'm working on a couple different ways to kind of look at that water quality. The end goal is to look at what's in that source water to start with, so you know how to purify. But right now, we're just kind of looking at what kind of the cleaner water that comes out of the purification device. But we have two ways we're looking at it. One way is kind of an electrochemical way, looking at cyclic voltammetry or square wave voltammetry. Basically, that can look at a signature and kind of correlate it to a concentration. And so we've done a whole bunch of work with heavy metals. And that takes a couple minutes, 5-6 minutes to get kind of a time to result. But the other thing that we're doing is, we just all went through COVID, right? So everybody can do a COVID test, a quick colorimetric lateral flow test. So in fact, one of the great things that kind of came out of that, if you could look at it that way, is, we can actually take a couple drops of water and put it on this test, this paper strip, and it will turn color in the presence of known heavy metals. So we actually can identify a couple heavy metals like arsenic, lead, copper, et cetera. And so that's instantaneous, right? That's a couple minutes. So you can get that quick, immediate result and saying, hey, this is compromised. We're still getting arsenic or lead coming through our purification device. Or, you can go to that lake or river stream, dip it in, and you get that color change. And you say, well, we know this is in this water now, so we should look out for it after we purify.
Yeah. Fantastic. I mean, you absolutely need to know before and after, right?
Yeah.
But the desalination device that you were working on, does that have any ability for a built-in test, or no, not yet?
No, not yet.
Okay.
But that being said, so if we go back to the kind of how that technology works, it actually has TIC-TIM, or toxic industrial material capabilities. So that's one thing
to remove
anything with a charge.
Right.
So we think it has bacterial capabilities, micro removal.
Yeah. Okay.
So that's one thing that I've really kind of looked at as we kind of move this hydration program along is, okay, great, we've got something that can remove micro, something that can remove chemicals, something that can remove salt. But can we start combining this to make an all-in-one system? Because, right, we don't need the soldiers carrying 3 or 4 different filters, right? That's not really helpful either. We're trying to reduce logistics, not increase it by reducing bottled water and now give them 3 widgets,
Right.
So really kind of, that's kind of the long-term roadmap, is to kind of get that all together in one system. So maybe we have 2 different systems for different, one for individual, one for squad, but, really kind of marrying these technologies as much as we can together.
Yeah. Well, you mentioned reducing soldier load, right?
Yeah.
I mean, water is heavy, right?
Yes.
So, and so you can only carry so much. You have to have resupply.
Yeah.
It is interesting. So I will tell you that I think, you do want to reduce the amount of devices you give a soldier to purify the water, right? Mm-hmm. But also to test the water,
correct,
right?
Yeah.
And at what level? Whether that's an individual, is that the squad, platoon, or is that even at the higher level? Because whoever's producing the water needs to be responsible for ensuring the safety and the quality of that water. So if you're getting it from an outside source like the brigade or something like that through a ROPU, they need to make sure that the water's potable, right?
Correct. Yeah. So, I mean, that's one thing that I think we also don't always think about soldier center technologies is that it can go up to that ground vehicle, GVSC, right? All the other RDECs can use this, Corps of Engineers, et cetera. So you really, we're not just, this technology isn't just soldier center, right? It can go across the DoD. And that's one thing that's really great about working here too, is like, okay, we're making a product, but this product can be, not only for the Army, but commercial,
right.
HDRE, human disaster relief efforts, like everything I do is just across the board products, right?
Now you see such an impact, right?
Yeah.
There's such a use and utility for it. Hey, talk to me a little bit about now, let's just transition. Let's talk about your work environment, like your space, your lab, kind of the work you do with international or even outside agencies. You mentioned a little bit about MIT.
Yeah,
I'm familiar with that. But anything else that might be interesting?
Yeah, so I'll start local and kind of branch out where we are. So right, I'm building 3. So I do a lot of the sensor work in where I sit in 322, but I also work in a shared combat feeding lab. That's where my analytical instrumentation is, and that we have a really great state of the art. Analytical lab
over in 16 or 36?
118 D118 for hydration. I worked with Jacqueline Fontecchio to really help build that out. We've got I could go down the list, but like ICP-MS, which we see heavy metals in. We've got LC, MS, GCMS. We've got these great analytical instrumentation, and not only is it great and state of the art, but we can start now looking at parts per billion, parts per trillion. So we can even get ahead of EPA guidelines and Army guidelines. And one thing I really want to try and use is for perfluorinated compounds right now, right? So you see that's a huge problem right now, and you're seeing all these agencies looking at it. But we've got the capability. Let's start doing the work.
Sure.
So that's kind of what I do in-house. But the other thing too is I get to work with a lot of great universities, right? I get to work with MIT. I get to work with Colorado State University. All these kind of leaders in fields, on the technologies we're working on. So that's great. So I get to visit the universities. I get to do work at the universities. I get prototypes or samples coming in, and I get to do in-house testing. So that's great. So I'm always flowing water with dose contaminants in and out, testing these water purification devices with different test waters, different contaminants in there, make sure it's purifying them. But then also I get to do a lot of field work, which is really great. So now this summer I was just in Thailand at the Crimson Viper field demo, and I tested my FCT, which is a non-thermoplasma device. I can test that in the field with real water and look at real microbiological destruction in real time. And that was fantastic because I got to work with another Army. I got to work with our own Army and DoD on that and get their input. So that was great to actually take something in the field and use it for what it's used for and actually see it. We weren't actually drinking the water out of it, but just we tested it and we showed that it's it's killing micro. And that's just that's an impact you don't get in the lab, right? Of course, we used a reservoir that had, sludge and all sorts of other stuff, right? This is what you're actually going to see in the field. You're not going to see this perfect, clean, simulated water with a little salt, a little dust in it. This was disgusting. Animals were drinking out of this, and we got to actually, test it, which was great. So that's one thing that I really appreciate about this job.
Any other international work?
Yeah, so I have a lot actually. So there's a foreign comparative test program. So that's started and has a couple more years left. So that where I get to take I'm actually using a water purification device we're calling Warfighter Water Purification, and that's a Chilean company. And I worked with them, and they were X-Tech winners actually. So that's how I learned about them, and DevCom Americas helped make that connection. And so so I get to work with them. I actually just went to Chile, and we got to do some lab testing there back in December. That was great, finally, to go down and see their labs and see how the technology is being made. But yeah, so I have that. And then there's, we have our ITCs. That is a huge, valuable resource, right? I work with ITC Atlantic, so that covers Europe. ITC Pacific, that's where a lot of my work is. DevCom Americas. Yep. So it's great that I can actually work with foreign universities to give them some seed funding, work with them because, you think, U.S. Army, America or bust. But actually, it's a great way to connect and actually build those, soft diplomacy relationships with other countries. Sure. Really work with kind of, lead scientists from other countries too, right? So, and that's really great too. So it's a great way to, the Army isn't just, we're, warfighters and weapons and,
Right.
and bullets. It's, this actual R&D that's actually making an impact too. So we get to build these connections that I wouldn't be able to build otherwise, right? Even if I was at an American university
Right.
in a lab, I might not be able to work with these other countries. So that's really great too.
Yeah, sometimes I think we tend to look in a little bit too much.
Yeah.
And you don't realize that all these other countries, right, that have armies are trying to solve the same problems that we're trying to solve.
Exactly.
And some of them may be ahead of where we are, right?
Yeah.
But if you think about all the resources just to attack this one problem that every country is working on, right? If you can harness that in some kind of group and get some synergies, you can go a little farther, right? You may be the push
for
to stay
sure.
where they are a little bit farther.
Yeah, but also like it's one of these things too where you can say, okay, this foreign university is working on this. It's a capability gap for like that allied country. It's like we could make a giant project out of it, and we could all work together to solve this problem instead of being insulated.
Absolutely. So
Yeah.
All right. Well, awesome. Hey, listen, I want to thank you, one, for leaving Dow and coming to us. It's a good benefit to us, obviously. But no, and your enthusiasm really speaks volumes for what you do here. I always tell everybody that it doesn't matter what you do at the Soldier Center. You all have a component to make our soldiers more lethal, and at the end of the day, make sure that they're survivable, right?
Exactly.
And you have a huge part in that. So thank you for what you do, and thanks for spending a little time with us today. Anything you want to say before we?
Thanks for inviting me for this. I mean, I hope to see this podcast, continue on, and it's great. This is another way for people to learn what we do here.
Yeah, absolutely. So all right. Well, thanks.
Thank you.